Hi guys, this is AS Chemistry, Analytical Chemistry, and we are doing infrared spectroscopy. Question 1. How many structural isomers with the molecular formula C4H10O give infrared absorptions both at approximately 1200 wave numbers and at approximately 3400 wave numbers? So these values correspond to, for the 1200 wave number, to a C single bond O group being present, and that at 3400 wave number, it corresponds to an OH group from an alcohol being present. So what we need to do is we need to make structural isomers of alcohol. So we can begin with a straight chain alcohol having 4 carbon atoms, which would be CH3, CH2, 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 and OH. This will be our first structure. We can change the position of the OH group from being on the first carbon atom to being on the second carbon atom, which would be CH3, CH2, CH, CH3, and OH being placed here. This will be our second structure. We can have CH3, CH, CH3, CH3 group being a substitute group, and then we can have CH2, OH being placed here. So this is our third structure, which means we can only have one more structure in which we can have a central carbon atom with an OH group placed on one end and three CH3 groups placed on the remaining positions on the carbon atom. So in total, we have one, two, three, and four possible structural isomers with the molecular formula C4H10O, making option B the correct option for this question. Question 2. Compound X contains 3 carbon atoms. Part of a simplified infrared spectrum of compound X is shown. Which compound could be X? So here we can see a narrow and sharp peak close to 1100 wave numbers, which corresponds to a C single bond O. So a C single bond O is not present in an aldehyde, so option A gets eliminated. It is present in the carboxylic acid, it is present in alcohol, and it is present in the esters. So this peak eliminates only option A. The peak close to 2900 corresponds to a C single bond H, which is present in all three. So this does not decide anything. But the peak beyond 3000 wave numbers, which is sharp and broad, corresponds to an OH group in an alcohol. So this eliminates the carboxylic acid because the peak for carboxylic acid would be between 2600 to 3000 wave numbers. And it eliminates the ester as well. So the only remaining compound with the OH group present is the alcohol, making option C the correct option for this question. Question 3. The infrared spectrum of an organic compound is shown. Which compound could give this spectrum? So the only identifiable peak in the given infrared spectrum is the one at 1700 wave numbers, which corresponds to a C double bond O group. So we have a C double bond O group present in option A, which is a carboxylic acid, but then there should have been a broad and sharp peak between 2600 to 3000 wave numbers. So that is missing, so it is not a carboxylic acid. For option B, we've got an alcohol group which does not contain a C double bond O group, so this gets eliminated. In option C, we've got a C double bond O group, making it a ketone, so this could be one of the correct options. In option D, we've got the C double bond O group again corresponding to the ketone, but we've got an OH group for an alcohol as well, which would give a sharp and broad peak between 3000 and 3600 wave numbers. So this is missing, therefore leaving only the ketone in option C as the one having the C double bond O group only, making option C the correct option for this question. Question 4. Compound S can be extracted from natural compounds. Reacting S with hot concentrated KMnO4 produces the organic product T. Some of the absorptions found in the infrared spectrum of S and T are described. S has no strong absorption between 1670 and 1740. That means S does not contain a C double bond O group. So, okay. T has a strong absorption at 1720, but no strong broad absorption between 2500 to 3000. So this means that it contains a C double bond O group, yes, but 2500 to 3000 is not there, so it is not C double OH. It cannot be a carboxylic acid. So from this information, what could be the formula of S and T? So S has no strong absorption between 1670 and 1740. So option A has a compound with a double bond present in it and it does not have any C double bond. So it could be option A with respect to S. It could be option B with respect to S. It cannot be option C with respect to S because C has got the C double bond O group present. It can be option D with respect to S. So T will decide which option is correct. So it should have a C double bond O and should not have a carboxylic group. So option A has a carboxylic group present, so it cannot be option A. Option B has a C double bond O group present, another C double bond O group present. So it can be option B. C has a C double bond O group present, another C double bond O group present, and another C double bond O group present. But this is not C double, this should be CH, 3 COCH3 and CH3. Okay, so this is a C single bond O, which is not there. And option D has a C double H group present, so this is eliminated. Looking at option C again, the second one from the left, CO, the first one is correct, the second one, COCH3, is once again an ether, not a carbonyl group. So option C is also eliminated, leaving only option B with the correct structures for S and T as given by the infrared absorptions in the question. Therefore, option B is the correct option for this question. Question 5. J is a branch chain alcohol, C5H12O. J is heated under reflux with an excess of Cr2O7 2 minus and H positive until no further reaction occurs. An organic compound K is formed in good yield. The infrared spectrum of K is shown. So the only identifiable peak in K is the one at 1700 wave numbers, which corresponds to a C double bond O group. So what are the structures of the branch chain alcohol J and compound K? So alcohol J would be a secondary alcohol and K is a ketone or an aldehyde. Okay, so in the case of J, we've got option A having a primary alcohol, which would be incorrect. Option B having a secondary alcohol. Option C having a secondary alcohol. And option D having a primary alcohol. So options A and D gets eliminated. We are left with options B and C. So option B has a ketone present and option C also has a ketone present, but we need to confirm the position of the C double bond O group in reference to the position of the OH group. So in option B, the third carbon should be the one with the C double bond O group present because that is where the OH group is. This part underline. So we have this here. So K corresponds with J. Whereas in C, we've got the second carbon from the right having the OH group And here we've got the second carbon from the right having the C double bond O group. We've got CH3, CH, CH3, CO, CH3. So CH, OH, CH, CH3. 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so let's make the structures to identify which one of them is incorrect. So for option B, we've got CH3, CH2, CH, OH, CH2, CH3, and this is converted into CH3, CH2, C double bond O, CH2, and CH3 in K. For option C, we've got CH3, CH, CH3, CH, OH, and then CH3 as J. And for K, we've got CH3, CH, CH3, C double bond O, and single bond CH3. So both appear to be correct. So this is a secondary alcohol for J and a ketone for K. This is a one secondary alcohol for J and the ketone for K. So both options seem to be correct here. However, looking at the question again, it started with J is a branched chain alcohol. So we can see that the alcohol in J in option B is a straight chain alcohol and not a branch chain, whereas in option C, this is the branching that is present. And when the question says it is a branch chain alcohol, it means the branching should be there. So this is the reason why option B gets eliminated and makes option C the correct option for this question. Question 6. The infrared spectrum of compound L is shown. What could be the structure of L? So the identifiable peaks in the infrared spectrum are the one close to 1000, which corresponds to a C single bond O, and the one that is sharp and broad beyond 3000 wave numbers, that should be for an alcohol OH group. So we have a C single bond O and an alcohol OH group. So what could be the structure of L? In option A, we've got an OH group, we've got a C double bond O which is missing, and we've got another OH group. In option B, we've got an OH group, another OH group, and an aldehyde group which contains a C double bond O which is missing in the infrared spectrum. In option C, we've got an OH group, another OH group, and a third OH group. In option D, we've got an OH group and a C double OH group which contains a C double bond O that is not there in the infrared spectrum. Therefore, this makes option C the correct option for this question. Question 7. An infrared spectrum shows a broad peak at 3000 wave numbers and a strong peak at 1710 wave numbers. Which substance could have produced the spectrum? So, the one at 3000 corresponds to an OH group from a carboxyl group, which means the OH should be attached to a C double bond O. And at 1710 wave numbers, it corresponds to the presence of a C double bond O group. Therefore, The presence of a C double bond O group has been confirmed with both the peaks, and the presence of the OH group attached to the C double bond O group is confirmed with the peak present at 3000 wave number. So this should be a carboxylic acid. Therefore, option A is an ester, option B is an alcohol, option C is a carboxylic acid, option D is a ketone, making option C the correct option for this question. Question 8. The infrared spectrum of a substance with empirical formula C2H4O is shown. Which bonds are responsible for the peaks X and peak Y? So peak Y is present close to 1700 wave number. So this should correspond to a C double bond O group. And peak X is a narrow and sharp peak close to 3000 wave numbers, which corresponds to a C single bond H. The only other peak that can be identified in this compound is the one close to 1200 wave numbers, which is C single bond O. So, which bonds are responsible for peak X? X is CH. So, options A and B contain CH. And peak Y is for C double bond O, which is not there in option A, and it is there in option B, making option B the correct option for this question. Question 9. The diagram shows the infrared spectrum of Q. What could be Q? So the identifiable peaks here are the C double bond O peak and the CH peak, and no other identifiable peaks present. So what could be Q? Butane 1-all. There is no alcohol peak present in the range of 3200 to 3600 wave numbers. So it can't be an alcohol. Butanoic acid would have an OH peak in the range of 2600 to 3000 wave numbers, which is not there as well. Butanone only contains the C double bond O group, which is present, and 3-hydroxybutanol. Now, it could be butanol, but because it says 3-hydroxy, so that hydroxy should be present between 3200 to 3600 wave numbers, so it gets eliminated as well, making option C the correct option for this question. Question 10. The infrared spectrum of compound P is shown. What could be compound P? So the identifiable peaks are the C single bond O, the C single bond H, and the OH group for an alcohol. So methyl ethanoate, we don't have a peak for C double bond O, so this cannot be the option. Propanol will also need to have a C double bond O group present, which is not there in the infrared spectrum. Proponic acid would need a C double bond O group to be present again, which is not there. Propane 2-all will have a C single bond O and an OH group for an alcohol present, which are both visible in the infrared spectrum of compound P, making option D the correct option for this question.